Okay, 8th grade, this is lesson 6.1 on functions. The first thing I want you to do is write down the definition of a function right here. It is a rule that explains what to do with the input value to get the output value. Now, the input value is what you put in, the output value is what you get out. There are 4 ways to represent functions. I want you to write these 4 down on your paper. Number 1, you can use a mapping diagram, which we'll see in example 7. Number 2, you can use a table, which we'll see in example 1. Number 3, you can use a graph, which we'll see in examples 12 through 14. And then number 4, you can write ordered pairs to represent functions, like we'll see in example 3. Okay, so the definition, like we said, assigns exactly one output value, which we call the y value the output value, assigns exactly one output value to each input value. So basically, you cannot repeat the x's. You can't have more than one x for a y value. All right, so write this down right here. Each x or each input can only have one y, one output. That is what makes it a function. So look at example 1. This one is a function, so circle the word function. This is a function. We have a table here of x values and y values. Now right here I want you to write input. The x value is the input, it's what you put in. The y value is the output, it is what you get out. And notice here that every x value has one y value. Write that down. Every x has one y. You put 4 in, you get a 6. You put 6 in, you get a 9. You put 8 in, you get a 12. You put 10 in, you get a 15. And so if we were to write a rule to represent this function, we would write this. Y equals 1.5x. Write that down. This is the rule to represent this function. So if I take this x value 4 and put it in where x is, well, 1.5 times 4 is 6. If I take the x value 6 and put it into the rule, well, 1.5 times 6 is 9. And the same thing happens for 8 and 10. You put 8 in, 1.5 times 8 is 12. And if you put a 10 in there, 1.5 times 10 is 15. Look at example 2. Is this a function? I have a table here of x values and y values. So look at your x's. Do you see any x values that are repeated? You should say yes. Right? This column right here, the first column, when x is 1, y is 4. But also in the next column, when x is 1, y is negative 4. And so no, is this a function? No, right? No, and circle it. That is not a function. It's not a function. Write this down. The input 1 has 2 outputs. It has 2 outputs. It has 2 y values. The x value 1 can't be 4 and negative 4, right? That x value 1 can only have one output if it's a function, but because it has 2 outputs, it has 2 y values, that makes it not a function. Okay, in example 3, there's 2 parts. There's part A and part B, so you can divide them in half right here. All right, now these are ordered pairs, obviously. And we want to say, is letter A here, is it a function? Now remember, it's an XY ordered pair. So this is X, that's Y. 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 Now look at your X values. Do you see any X values that are repeated? You should say yes. Here's an X value, and here's an X value that are repeated. I have 2 X values, 2 inputs. And those 2 inputs have more than one output, right? Because if you put a 5 in, you get a 1. But also if you put a 5 in, you get a 3. Well, that eliminates it from being a function because you have more than one output. So you're going to write no for letter A. No, that's not a function. Look at part B. Part B, you have negative 3, 0, 0, 1, 3, 2, and 6, 3. Okay, so again, you can have no repeating x's. You cannot have an x value that is the same, otherwise that eliminates it from being a function. So I have negative 3 for my x value, I have 0 for an x value, 3 for an x value, and 6 for an x value. So I see no repeating x's. So yes, this is a function. It is a function because you have exactly one output for each input. All right, so write no for A and yes for B. In example 4, complete the table and write the rule. So what I'm looking here, the rule, like I did up here in example number 1, I want to see how do I get from X to Y? How do you get from X to Y? Well, to get from 3 to 12, I would multiply by 4, right? 3 times 4 is 12. 5 times 4 is 20. 7 times 4 is 28. So it looks like I'm multiplying by 4, but as you can tell, all these y values are negative. So I'm not multiplying by 4, I'm actually multiplying by negative 4. 3 times negative 4 is negative 12. 5 times negative 4 is negative 20. 7 times negative 4 is negative 28. So to get y is negative 4 times whatever x is, right? We take your x value, multiply it by negative 4, and you get y. So this rule right here, y equals negative 4x, is the rule to represent the function. Now let's complete the table. If you put a 9 in, for x, you would have negative 4 times 9. Well, what's negative 4 times 9? Well, that's negative 36. So I realize the table is a little dark there, so just put a negative 36 and draw an arrow to where it needs to go. It needs to go right there. Okay. Now in this final column, go ahead and leave that blank because in there we would write the rule, y equals negative 4x. Okay, example number 5, let's also write a rule to complete the table. So how am I getting from x to y? From 100 to 50, from 80 to 40, from 60 to 30? Well, you could say you're taking the x value and you're dividing them by 2, right? 100 divided by 2 is 50. 80 divided by 2 is 40. 60 divided by 2 is 30. So to get y, you're taking x and dividing by 2. Taking x and dividing by 2. So if x is 40, if you put 40 into the rule, 40 divided by 2 is 20. 20. Okay, number 6, is this a function? Angie bought 2 pencils for 50 cents, 3 pencils for 75 cents. Mike bought 5 pencils for $1.25. What rule represents this function? Okay, now I want you to draw this table right here. We can make a table to represent the situation. So I'm going to make an x value of pencils. That's going to be my input, and my output is going to be the dollars, which is the y value, right? And I'm just going to fill in what this says. So 2 pencils cost 50 cents. 3 pencils cost 75 cents. 5 pencils cost $1.25. Okay, so based on this information, how am I getting from x to y? Well, I'm taking every pencil and multiplying it by 25 cents, right? So to get y, to get the amount of money, which y is the variable that represents the amount of money, to get y, I take 25 cents, which is 0.25, and I multiply that by the number of pencils, which is represented by x. So whatever x is, that's the number of pencils, multiply it by 25 cents, and that would give you y, the amount of money that you have to pay. And so yes, this is a function because there's exactly one output for each input. I have no x values that are repeated in the situation. Okay, in example number 7, we have the first mapping diagram. This is a mapping diagram. Now, the oval on the left is always the input. On the left is always the input, so write input. And on the right is always the output, right? Output. All right, so you're putting these numbers in and you're getting these numbers. Now, as you can see, I have 3 numbers on the input, 3 input numbers. If I have 3 input numbers, I should have 3 arrows going from the input oval. And as you can see, I have 1 arrow, 2 arrows, 3 arrows from the inputs to the outputs. Okay, so what this is showing me is that every input has exactly 1 output. And so that is the very definition of a function. So yes, this is a function. If there's 3 inputs, there should be 3 arrows going out from that oval section. Okay, example number 8 on the back side. Again, I have a mapping diagram. I have 1, 2, 3 inputs, right? 3 inputs. So if I have 3 inputs, I should also have 3 arrows going from the inputs to the outputs. 3 arrows going from the inputs to the outputs. Well, how many arrows do you see? I see 1, 2, 3, 4. I see 4 arrows going out from the inputs. And what that's showing me is that there is some input number that has more than 1 output. And that would be the number 2. Do you see how the number 2 has 2 outputs? It goes to number 5 and to number 16. And that can't happen for it to be a function. So because this input number 2 has 2 outputs, that makes it not a function. So no, this is not a function. Example number 9. Again, I have a mapping diagram. I have 1, 2, 3 inputs. There are 3 inputs. Okay? Now outputs, you can see I have 1. But if I have 3 inputs, how many arrows should I have going from the inputs to the outputs? I should have exactly 3. And how many arrows are there? There are 1, 2, 3. So yes, this is a function. Please pay attention here. This is a function because each input has 1 output. Now, I know you may be saying, well, it's the same output. That's okay. It can happen. 2 or more inputs can have the same output. That's okay. As long as you have the same number of arrows that you do inputs. Here I have 3 input numbers and 3 arrows going from the inputs. That makes it a function. So yes, this is a function. Number 10, I have a table. Identify whether this is a function or not. Well, look at your x's. Do you have any x values that are repeated? 5, 10, 15, 20, 25, 30. No, I have no x values that are repeated. Okay, so yes, this is a function. No x values are repeated. Example number 11. Do you have any x's, any inputs that are repeated? So look at your x's, your inputs. I have 1, 5, 4, 1, 7, 3. Do you see any numbers in this row that are the same? You should say yes. I have 2 1s, right? 1 is going to a 10 and 1 is going to a 4. And so I have more than one output for this input. So that makes it not a function because no x's can be repeated. Okay, in these last 3 examples, 12 through 14, I want you to write this down. We're going to use the vertical line test. The vertical line test will help us determine, just by looking at a graph, if that graph shows whether a function is being showed or not. Okay, now looking at example 12, if I were to take a vertical line, which is an up and down line, and slide it across the graph, there should be no dots on top of one another. So if I take this ruler to represent my vertical line and slide it among the graph, I'm going to slide it until I see 2 dots stacked on one another. At this point right here. At this point right here, do you see this vertical line where those dots are stacked on top of one another? And if that happens, that means that this graph fails the vertical line test. Right? If one dot is directly above another dot, then the graph does not show a function. Okay, so in example 12, this is no, not a function because it fails the vertical line test. Be sure to write that down. It fails the vertical line test. Example 13, again, I'm going to use the vertical line test. I don't even need to know any of the values in the graph. If I take a vertical line and slide it across the graph, there should be no dots on top of one another. Okay, I'm good, I'm good, I'm good, I'm good, I'm good, I'm good. All the way across, there were no dots stacked on top of one another. So, yes, this is a function. It is a function because it passes the vertical line test. Be sure to write that down. It passes the vertical line test. Last one, example number 14. Is this a function? Does it pass the vertical line test? So let's see. Does it pass the vertical line test? I'm going to slide my vertical line across the graph and see if there's any dots stacked on top of one another. I'm good, I'm good, I'm good, I'm good, I'm not good. Do you see these dots? They're stacked right on top of one another. They're right on top of one another. So that means that it fails the vertical line test since the x value, that x value, which here is 3, the x value is 3 right there, that x value has more than one y value. All right, so that means no, it's not a function because it fails the vertical line test. And circle that.